In the nervous system, a synapse is a structure that permits a neuron to pass an electro or chemical signal to another neuron or to the target effector cell. If we say that the Earth is a neuron and the universe is our brain, the space city is just like the synapse of this little neuron. But these little synapses build up an astonishing human piece, making us sensible and advanced. That set us wondering, how can a small space city affect the whole universe? So welcome to this amazing project, Synapse. In this video, we're going to introduce a space city scheme which is presented in 6 parts. Hope you could enjoy it.
So let's start by understanding the overall structure and components of Synapse. The main part, the space settlement in NRHO, is built by 5 types of compartments. The core compartment, the linking compartment, the module compartment, the transition compartment, and extended compartment. The 3 forward compartments are the main components of Synapse. The core compartment is the first compartment that we launch to the orbit. Since it's the start point and the center of Synapse, it's the crossing of the 4 arms of Synapse. The transition system and the arms cross here, so this is the crossroad inside Synapse. The linking compartment is the structure extended from core compartment. It's the component of the cross of Synapse. As you can see, each linking compartment has a branch docking port that allows transition compartment to dock to it. Also, there are a dual-rail transportation system in Synapse that allows people and boxes move efficiently in these extreme long arms. The transition compartments are the compartments that dock to the branch port and linking compartments. As the diameter of linking compartments are 9 meters only, the module compartment's diameter is 23 meters, so we have to transform the diameter from 9 meters to 23 meters, and that is the function of the transition compartment. The module compartments are the main compartment of Synapse. Throughout our design stream, there is a central concept, that is, all your design should be highly modular. Thus, every module compartment has one external design, but its content will be different. Thanks to this, our module compartments can dock to each other easily, and this will make the inner structure design easily. There are basically 3 types of module compartments. The first type is what we call agricultural model. In AM, we culture potatoes, spinach, and a kind of algae to produce food and essential nutrition, and also transform carbon dioxide to oxygen at the same time. This is the main food and oxygen source of Synapse. The second type is the living module, where all the functions that are associated with the living conditions to the citizens will be here. There will be sleeping compartments, entertainment compartments, kitchen, and also a small but useful hospital. We'll talk about this later in the section for the residential design. The other type of compartments is the research module, where we are going to accept research devices from all the governments and organizations that can fit our condition. They will pay a small sum of money, and this will be the main source of profit during the building period of Synapse. So this is the basic information about the components of Synapse. But how do we use them to build Synapse? The first period is to place the core compartment in NRHO. The core compartment will not move when Synapse is assembling. The second period is to build and extend the cross of Synapse with the linking compartment. The third period is to install the research compartments. As research compartments are the main source of income of Synapse, we have to build them and install them first. During the last period, we are going to install all other module compartments. After this period, the installation of Synapse in phase 1 ends.
Launching such an enormous space city to NRHO orbit does need some processes. We decided to use the Sea Dragon Starship Ferropush Association plan. Sea Dragon is designed by Robert Turek, while the Starship is developed by SpaceX. Ferropush is an original thruster concept that could boost cabins and accelerate it to the NRHO orbit. The whole plan aimed at the maximum amount of reuse and the choices of the most economic rocket. By that, the whole plan is theoretically realizable.
So what about our orbit, the location of our project? A good question. There are many aspects to consider. As a project which is designed for a close future, we choose to position our project on the orbit of our nearest friend, Moon. Our station is located above the Moon in our orbit called NRHO, which represents near rectilinear halo orbit. This orbit is an elliptical orbit, which will bring the station within 1,500 kilometers or 930 miles of the lunar surface as closest approach, and as far away as 70,000 kilometers on a 6-day orbit. So why do we choose this orbit? One reason is that due to the low area of solar panels, we need a longer direct solar radiation time to get enough energy. In this orbit, we can always receive direct sunlight. Another reason is that it only costs less than 10 meters per second of delta V per year to sustain the orbit.
Now we are going to move on to the next part, the life supporting system design. Since Synapse can hold more than 100 people in phase 1, we have to build and design a thorough life supporting system. As the main element of life, that includes oxygen and carbon dioxide transform balance, the food producing system, the water cycling system, and the main source of necessary elements. In this part, we are going to show you how these functions really work out. Firstly, we are going to talk about the oxygen and carbon dioxide transition in agricultural module. As we are not going to transform carbon dioxide to oxygen in the way of chemical reactions like what International Space Station practiced, so the agricultural module is extremely important in our stream. In agricultural module, we mainly culture some vegetables and a kind of algae. This produces most of the oxygen cycling in Synapse. As the chart shown on the screen, spinach and potato have a rapid carbon dioxide-oxygen transition velocity, and they are the main source of staple food and vegetables in Synapse. The amount of these two species cultured in Synapse will be abundantly huge, thus most of the oxygen generated in Synapse comes from them. And as for algae, we mainly use them as a way to balance the speed of transition. Because the dominant condition of oxygen generating speed is light for algae, we can control the light to control the balance of oxygen and carbon dioxide. Also, algae are an important part of measures we take to deal with sudden oxygen decrease. And the next part we are going to introduce is the water cycle in Synapse. The cycle is divided into two separate systems, the agricultural system and the living cycle. Let's introduce the agricultural cycle first. The agricultural cycle is the cycle which plant nutrition solutions flows in it. The water goes through each cultural cells and passes the purifying system for agricultural module, and goes into another turn of cycle. Also, the gas cooling system will cool down the gas and receive water from the vapor in it. Another cycle is the living cycle. Most of this cycle is the same as the agricultural cycle, but in its purifying system, we use a worm to chew down most of the waste and turn them into necessary nutritions.
The transport bar is a hollow tube with a central bar inside to provide electricity. There are upholders connecting the central bar and the tube to support the structure every several meters. In this transport bar, magnetic acceleration is used as power source. It can provide service for a very long time, and it has high stability and low servicing fee. Moreover, once it has some malfunctions, the fee needed for repairing is relatively low. In addition, magnetic suspension makes the transport of residents more convenient. Magnetic can accelerate and decelerate easily, so passengers can leave their vehicle at any time and anywhere. Passengers can make the vehicle to accelerate and decelerate by operating the controller installed in the handle. In the case of emergency, there is an infrared sensor equipped in the vehicle that can detect objects laid in the road and activate the acceleration. Every member in Synapse holds a hologram. It appears to be a pen which is light and easy to hold with. But when we shake it for twice, the hologram inside will automatically bump out. The hologram contains two sections. The left-hand side holds the user's complete information and health condition, including heat, weight, and health relative index, etc. The right-hand side mainly demonstrates the user's increase in Synapse and also his or her working completion progress. Each hologram is split up by the owner's digital fingerprint and 3D face recognition. When the user logs in, the record will be snitched back to the mainframe and the lockoff library, an independent database that will track and archive any information that may be wiped out when the mainframe is accidentally hacked or damaged. The people in the settlement sleep in a sleeping capsule. The sleeping capsule spins constantly to create a gravity acceleration approximately the same as the gravity on the Earth. However, if only sleeping capsule spins, angular momentum will become so large that the station itself may start rotating. To avoid this, there's a tube-shaped part rotating in the opposite direction of the sleeping capsule's rotation, balancing angular momentum. When decelerating or stopping the rotation, the engine can also recover some energy.
Moonbase is another half of the whole dream of the space station. In order to construct an experimental colony, we have some preliminary conceptions. The Moonbase still continues our module design. Module design is the best for early developments because of the repeatability and simplicity for machines. These module compartments are named the octamer. The octamer contains the main construction and 8 co-constructions. 8 co-constructions are placed perfectly in a central symmetric way and tangent to each other, with gates connecting the joints. The octamer plays a role as an independent ecosystem. Co-constructions will undertake different tasks to maintain the condition of surviving, while the main construction is designed to have the ability of transporting, commanding, and serving public services. Generally, an octamer is a unit society with the ability to rely on its own efforts. No matter what new technology will develop and affects our energy source or life supporting, it is just side issue. Anyhow, this is the first try of human to live somewhere far from the Earth. Another important part of our lunar plan is the lunar industry. Here we use the minerals as an example. Raw materials are very important to set up a complete industry system, but we are happy to know that critical elements such as aluminium, ferrum, magnesium, and titanium have a high abundance on the moon. Besides the basic conditions, rare earth elements and other mineral resources such as helium-3, which have potential values, are also attractive. All of these gives us the confidence to say that the moon will be an ideal place to give a first try of space industry. Beyond all doubt, it will cost a lot to complete the whole project, both money and time. But now we just want to discuss that whether human can take the first step, which is phase 1, to build a complete space station, the Synapse, in a short period such as 20 years, in order to play an important role as an outpost in the long history of space exploration. The first stage investment basically contains 3 parts: researches, production, and launching. As the diagram shows, the estimated final costs are around $30 billion, which is quite an acceptable number. However, this is only about 40% of the original budget. We have come up with some idea to cut down the budget. Even we chose the Starship and the Ferry-push plan to make a maximum use of every thruster, Sea Dragon rocket just has a pathetic cost preference. In order to solve this problem, the most practical and effective solution is to make a good reuse of the upper stage of the Sea Dragon rocket. The cabin of the upper stage roughly has the volume of 20,000 cubic meters, which is as 20 times big as NIS, International Space Station. In that way, we not only prevent the waste, but also offset nearly 80% of the excessively expensive launching cost. New materials and technology such as high-efficiency photovoltaic power generation or 3D printing may appear in the coming decades, which could reduce some pressure too. But the most ideal situation in the future is to develop with the moon base together, genuinely on our own. For the whole project, the potential economy value is infinite, not only providing a platform to explore the further space, but also leading human to a great future, even if what we have done is just an inappreciable trail. So again, let's see what this project could bring us. Human is a species which are always seeking for something, and that is the origin of that adventurous heart. The only thing Synapse will do is just to be a small synapse in the whole tremendous nervous system, doing its little part and serves for the glorious future. On the way to our dream, the project is divided into 3 or more phases. For each step we made, we became closer to our heart. One giant leap for mankind. This is a great oath that we'll never forget. Through the long history of mankind, countless of people sacrificed their life in following our own heart. We desire to be one of them.